Hello everyone. Last week we discussed electric force between the charges and we used Coulomb's law, which defines the electrostatic force of attraction or repulsion between the charges. We also discussed system of charges where one charge experiences the force due to the other charges. The resultant force we found by using the vector method. Today we are starting with the electric field, our electric field intensity, our electric field strength. So first we want to find the strength of the electric field at point P, which is at a distance r from a given charge capital Q. So we are interested to find the electric field at point P. By definition, the electric field is electric force per unit charge. So we will see how much force is experienced by each coulomb of charge when placed at point P. So we will place a test charge small q at point P to see how much force it experiences. So at this point we placed small charge test charge q and we want to find what is the value of electric field here. We need the force between the charge capital Q and the small q. By using the Coulomb's law, we can find the force is equal to K capital Q small q divided by the square of the distance between them. Now using this value over here, we can write the value of electric field is equal to force divided by the charge which experience this force. So now you can see that small q is cancelled and we are left with kq over r square. So in order to find the electric field from a charge capital Q at any distance r from it, we actually don't need any other charge. So we can find the value of electric field at that point by just using what is the magnitude of the charge for which we are finding the electric field and where is this point P. So in order to find the electric field due to a single charge, we need two things. One is the amount or magnitude of the charge and the other thing is the distance. And we can see from here that the value of electric field changes with 1 over r square. And this law is called as inverse square law, which we discussed in topic of electric force also. So the variation of V with distance r follows this law. It means if we have electric field on the y-axis and distance on the x-axis, distance means distance from the charge. And the meanings are still the same, that when you double the distance, the value of electric field will be 1/4. And you can see from here, at a distance of 1, the value of electric field is 8 and double the distance, the value of electric field become 2, which is 1/4 of 8. So electric field due to a single charge also follows the same law. We have a system of charges, two positive charges and two negative charges. We are interested to find how much is the value of electric field at this point P due to the all other charges. So what we do, due to this charge, the electric field at point P can be given as this way. Electric field due to this charge at point P is given in this way. The electric field due to the negative charge at point P is given by this way, and electric field due to the fourth charge at the point P is given in this way. So what we do, we find the value of electric field due to each charge. For example, I say this as Q1, this as Q2, this as Q3, this as Q4. So we find the electric field due to the charge Q1, which can be given as E1. So this is electric field due to the second charge, due to the third charge, due to the fourth charge, and we add it all together. Keep in mind, I wrote the value of the electric field in terms of the vectors. So the electric field, for example, for the Q1, the distance is R1. So by using the law, we can write K Q1 divided by R1 square. So in a vector form, I can write this as K Q1 divided by R1 square, the unit vector R1. Unit vector R1 means this direction. So this is the reason we can write them by just adding. Keep in mind, we are not taking the sign of the charge, whether it's a positive or negative. We only take the magnitude. The direction, we will take care of this when we will make the coordinate axis. So in the subsequent example, you will see that how can we actually incorporate the direction of the electric field. We can also write a vector sum of all these in this way. So we do the vector sum. So for any system of charges, we can calculate the amount of electric field at a certain point P due to all other charges. We use the vector sum of the electric field. What we need to consider is the direction of the electric fields. We start with a very simple example and then we put some complications. We have this kind of situation, two charges Q1 and Q2, and we are asked to find what is the value of electric field at point P. So due to the negative charge Q1, the value of electric field at point P is towards the charge. And due to the positive charge Q2, the direction of the electric field at point P will be away from the charge. So what else we are supposed to do is to find the values of E1 and E2. Both are in the same direction and we can take left side as positive. So the resultant electric field will be towards the left direction. So rest of the thing is E1, which is given by K q1 divided by the distance of the charge from the point. And you can see this is 2 centimeters. So 2 into 10 power minus 2 squared. Similarly, E2 is the value of the electric field at point P due to the charge Q2. So we can write K Q2 and the distance is 8 centimeter, that is 8 into 10 power minus 2 whole square. The resultant electric field will be E1 plus E2. So we are taking left side as positive, so the resultant electric field will be towards the positive direction. So you are only supposed to put the value of K, which is 9 into 10 by 9, and the values of Q1 and Q2. Okay. Now, we have two charges. One is 5 microcoulomb. The other is negative 5 microcoulomb because this charge Q1 is negative and Q2 is a positive charge. They are placed at a distance of 20 centimeters from each other. You are asked find and justify the zero field location. Zero field location means where there is no field. It means the field of both charges cancel each other. So for cancellation, there are two requirements. Zero field means number one, fields must be opposite and they can cancel each other if they are equal. So fields must be equal also. For example, we consider three locations. Towards the left of both the charges, towards right of both charges, or in between the two charges. So for example, let's see the electric field due to the negative charge is towards the charge and electric field due to the positive charge is away from the charge. So here in between the charges Q1 and Q2, the electric fields are in the same direction. Therefore, there is no possibility that the electric field could be zero between Q1 and Q2. The situation will be different if the signs of Q1 and Q2 are same. So then you can have actually in between the opposite direction. But here for two oppositely charged, one negative, one positive, we cannot have a zero field between the charges. So now, what about A and what about B? So for A, the electric field due to the negative charge, it's towards the charge. I write it as E negative. And for the positive charge, the electric field at point A is away from the charge. So here the electric fields are opposite. So there is a possibility of having zero field. Similarly, at B, the electric field due to the negative charge is towards the charge and electric field at point B due to the positive charge is away from the charge. So there is a possibility of having the zero field at A and zero field at B. But there is a possibility only at one place. At B, this is not possible because you know the electric field is k q divided by r square. Irrespective of the distance, if you see, the electric field depends upon the amount of charge, and the amount of charge of q2 is larger. It means the electric field of q2 is stronger at the same place as compared to q1 when at the same distance. When they are not at the same distance anyway. So due to the charge, q2 is a stronger charge, so due to that electric field is stronger. But because the point B is closer to the stronger charge, so the electric field of q1 is already weaker because of the smaller charge, and when we go more away from it, it gets more weaker. So there is no possibility that the electric field at point B could be equal to point A because of the larger charge. And there is a possibility that the electric field of a stronger charge at a larger distance could be a smaller electric field equal to the charge of q1. So there is a possibility at A. In short, the result is the electric field in these kind of situation is always equal to each other, closer to the smaller charge. Okay, so due to the smaller charge, so we can write E plus at A is equal to E negative at A. So you can write K Q1, uh, E plus is due to the Q2, so Q2 divided by the distance. So what I'm doing is I consider the position of Q2 as 0 and left side I take positive, right side is negative. So there is an advantage actually to consider this. Then only your positive answer is possible. So from Q2 to the point A, the distance could be 20 plus x. And due to the Q1, K is cancelled. Q2 is 25 microcoulomb divided by 20 plus x. I did not change this into the meter. There is no need actually because on both sides it appears. And 5 into 10 power minus 6 x square. 10 power minus 6, 10 power minus 6. 5 is also cancelled. So you can write 20 plus x whole squared is equal to 5x squared. That makes a quadratic equation. So we can write 5x squared equal to x squared plus 400 2 into 20 into x plus 20 squared 400. So we can write that this is equal to 5x squared minus x squared minus 40x minus 400 equal to 0. So that is 4x squared minus 40x minus 400. Then you can use the quadratic equation. You will get two answers of this, one positive, one negative. So positive is your answer because you took the direction of positive towards left. The negative answer is not possible because we have seen that towards our right, this is not possible to have zero electric field. So we justified that only at a point the electric field is zero, and then by using this quadratic equation, we can find what is the value for x. So you would consider only positive value of x.